All right, here we got the 8.1 notes, trig review and intro to the unit circle. Okay, now like I said, this is trig review. Pretty much everything we do on here is going to be stuff you learned last year in Math 2. So if you remember that stuff, then this should be pretty easy. At the same time, though, this one section covers pretty much everything that you did in Math 2 last year in regards to trig. All right, so let's dive right in. First of all, one of the things that hopefully you do remember is SOHCAHTOA. Now they split it up here into three parts of that word, SOHCAHTOA. And the spelling of that is very important because that tells us a couple of relationships. If we want to know the sign ratio, and again, that's what this whole thing is about, is ratios. In other words, just fractions. So what's the sign ratio? Well, they just want to know what's the opposite side over the hypotenuse of your right triangle. If they're asking for the cosine ratio, they just want to know what's the adjacent side of your right triangle over your hypotenuse. And if it's your tangent ratio, what's the opposite side over the adjacent? Again, opposite and adjacent, those can switch depending on which angle you're talking about. Okay, so for example, the tangent of A is going to be different than the tangent of B, because one's going to be 9 over 40, the other is going to be 40 over 9. So anyways, it's just all about ratios. Okay, so again, SOHCAHTOA is important to know. S is for sine, C is for cosine, T is for tangent, and then anywhere you see an O, that's going to be an opposite side, H is our hypotenuse, and then A is our adjacent side. Okay, so example number 1, it says find the sine, cosine, and tangent ratios for angle A and for angle B in the following triangle. So we got this triangle here. Okay, well great. We got these two legs of our triangle, which depending on which angle is going to be the opposite side or the adjacent side. But then we also need to know to find sine and cosine, we need to know the hypotenuse. Okay, so sometimes we need to find that missing piece. So another thing that we learned last year, that was the Pythagorean theorem. If we're given two sides of a right triangle, how do we find the third? I'll use the Pythagorean theorem. So let's see, my missing side is my hypotenuse. So then we can say, now this might be a little confusing because there is a C here, that's one of my angles, but typically we say, a squared plus b squared equals c squared. Okay, so we're going to call our missing side of our triangle C. In fact, that's confusing. Let's change that up. We'll just call it x. So I want to know how big is this hypotenuse here. Okay, well, I know that 40 squared plus 9 squared equals my hypotenuse squared. Okay, so then we just want to solve this equation. 40 squared, we get 1600 plus 81 equals my hypotenuse squared. We'll add those together, we get 1681. Okay, and then we don't have to simplify that by hand. You can use calculators in this unit. So take the square root of that number, and fortunately it works out nice. It's a whole number. We get x equals 41. Okay, so then we know the hypotenuse of our triangle is 41. Okay, and then now that we have all three sides of our triangle, well, now we can find the sine, cosine, and tangent of both of our angles very easily. Okay, what is the sine of angle A? So if I'm looking at angle A, this one here. Okay, well, in relation to angle A, what's the sine ratio? In other words, what's the opposite side over the hypotenuse? Well, the opposite side has a length of 9, so then it's going to be 9 over my hypotenuse is 41. So then 9 over 41, that's our answer. That's what we're looking for. Okay, what is the cosine of angle A? And one thing that you can do, which is optional, now I'm not going to do it because we're going to switch up our angle we're using in a minute, but when you're dealing with a certain angle, angle A, if you want to label your sides, this is the opposite side, this is the adjacent side, and this is the hypotenuse. Okay, opposite side is easy, it's the one that's across from your angle. The hypotenuse is always the one that's longest, which is across from your 90, and then the adjacent side is that other third side. So it's the one that's next to your angle that's not the hypotenuse. Okay? So we're not going to label opposite, adjacent, and hypotenuse because the opposite and adjacent are going to switch when we look at angle B. Okay, but cosine of angle A. That's my adjacent side, 40, over my hypotenuse, 41. And then that's all they want is that ratio. Okay, what about the tangent of angle A? Well, tangent is opposite over adjacent. So it's the opposite side, 9, over the adjacent side, 40. So 9 over 40. And that's all they want is that ratio. Sometimes we'll do more with those ratios. Sometimes we just want to know what is that ratio. In this case, we just want to know what it is. Okay. Next, what's the sine of angle B? So we'll switch to red here. If I'm looking at this angle now, angle B, what's the sine of angle B? Well, now the opposite side of angle B is going to be 40, and the hypotenuse is 41. So instead of 9 over 41, this one is 40 over 41. Okay, in relation to angle B, what's the cosine of b? Well, cosine is the adjacent side over the hypotenuse, so that's going to be 9 over 41. Okay, and then the last one, for angle B, tangent would be 40 over 9. Okay. One thing you might want to notice, if you're dealing with one triangle and you got two angles A and B, okay, your two acute angles, you're never going to use your 90-degree angle. The sine of A is the same as the cosine of B. The sine of B is the same as the cosine of A. So, there's a lot of relationships like that you don't necessarily need to memorize, but there are a lot of patterns that are good to know. Okay. Anyways, we won't point out too many all at once. We're mainly going to stick to things that we're reviewing from last year. Okay, this is stuff we did last year. All right, next, example number 2. It says solve for x using right triangle trigonometry. So this time we're actually going to put it in an equation and solve. Once you've solved for x, use a scientific calculator to approximate the value to the nearest 1,000th. Okay, so here, we want to find the missing side of our triangle. Let's zoom in on this problem. That's a little better. Okay, so how do we find x? Now, first of all, do we have to use trig? Okay, because keep in mind, trig is kind of a last resort. Okay, but can we do it, say, using the Pythagorean theorem? Well, no, because I only know one side of my triangle. If we know one side of our triangle and one of our angles, that's when we can use trig. Okay, all right, so we always have two options. We can use the acute angle given to us, or since I know that these three add up to 180, or even easier, these two angles add up to 90, well, then I can use either one of these two angles. Okay, we're just going to stick with the one that's given to us, this angle right here. All right, so we're going to use trig. Well, which trig function are we going to use? Are we going to use sine or cosine or tangent? Okay, well, let's see. In relation to our angle, which two sides did they give us? Well, they gave us one across from it. That's the opposite side. And then across from the 90, our longest side here, that's the hypotenuse. So in relation to our angle, they gave us the opposite side and the hypotenuse. Well, which trig function uses opposite and hypotenuse? Well, that's when we look up here at SOHCAHTOA. And then opposite over hypotenuse, well, that's our sine function. Okay, so then we want to use the sine function. Okay, so then we know the sine of our angle. It's always of an angle. So sine of 71 degrees, we know that equals what? Well, x over 24. Okay, and then there's our equation. And then once we have an equation, well, sure, we can solve that for x. We just got to do some algebra. Okay, let's see. I want to get x by itself. Right now I have x divided by 24. Well, what's the opposite of dividing by 24? Multiply by 24. So then I just want to multiply both sides of my equation by 24. Now, one of the most important things to remember when you're doing these types of problems, what is sine of 71? Well, it's some number. Okay, let me show you something real quick. If we look at a scientific calculator, if I punch in, try to get where I can see it, hopefully the glare is not too bad. Turn it on first. If I use the sine button and then punch in my angle, 71 degrees, what's that equal? 0.9455, keeps on going. Hopefully, again, you can see that. Try to block out the glare without blocking the camera. 0.9455. So anyways, the sine of our angle is just some number, some decimal. If I wanted to, I could replace this with some decimal. Okay, but that's kind of like using 3.14 instead of pi. Okay, we'd be approximating our answer. If we want the exact answer, we'll just leave that in there. Okay, and when I multiply both sides by 24, well, these reduce to 1. Those basically cancel, and I get x by itself equals 24 times whatever that number is. Okay, so really this is our exact answer. This is like having pi in our answer. Okay, and then what if we said, okay, we don't want pi, we want a decimal approximation? Well, then what would we do with that? Well, we punch it in a calculator. So then I take the sine of 71 degrees, which we already have right there, and then I want to multiply that times 24. I didn't have to enter it in this order, but we already had this sine of 71 in there, and we get it's about 22.69, so let's say about 22.7. So then x is approximately 22.7. Okay, and they didn't say if it's feet, inches, or whatever. We'll just leave it as 22.7. Okay, so there's our answer. All right. Next one. Okay, so same kind of process. We're given one angle and one side, and we want to find another side. Well, since we only have one side of our triangle and an angle, we want to use trig. Now, in relation to this angle that they gave us, which two sides are we given? Well, this is the side across from our angle. This is the opposite side. And then this is next to our angle, and this one's the hypotenuse, so this would be the adjacent side. Okay, so this time we're given the opposite side and the adjacent side. Well, which trig function uses opposite and adjacent? Well, then we look back up to SOHCAHTOA. Well, opposite and adjacent, that's going to be tangent. So we want to use the tangent of our angle this time. Okay, again, it's never just sine, cosine, or tangent. It's always sine of an angle, cosine of an angle, or tangent of an angle. So it's the tangent of our angle, 28 degrees. And remember, what is tangent of 28 degrees? Well, it's some number, some decimal. But we're going to leave it like this because this is the exact answer. So the tangent of our angle we know is going to be the opposite side, 15, over x. Okay? All right, so then there's our equation. Now we want to solve for x. Okay, now I'll show you the long way to do this, working out the all the algebra here. But then we'll show you a little bit of a shortcut at the end for when you get problems like this. Another option is maybe use this angle instead, because we can figure out this angle and this angle, they add up to 90 degrees. So this one's going to be 62 degrees. And then tangent of 62 would be x over 15. I like the x in the numerator better. There's less algebra to do. Okay, but anyways, we can solve this. The first thing I'd want to do is get x out of the denominator. So I got to multiply both sides by x. Okay, and that's going to move it up here. These cancel here, and then I get x times whatever the tangent of 28 is. Again, that's just some decimal. Equals 15. And then now, to get x by itself, I want to divide by whatever the tangent of 28 is, whatever that decimal is. And then these cancel, and then I get x equals whatever 15 divided by the tangent of 28 is. Okay, so that's my answer exactly. And then what if we want a decimal approximation? Okay, well, I can just take my scientific calculator, try to get it where there's no glare. Good enough. And we want 15 divided by the tangent of our angle, which was 28 degrees. And then punch that in the calculator, and we get about 21.21, so about 21.2. I'm sorry, 28.2. I was looking at the decimal. So x is approximately 28.2. Okay, and then that's our answer. All right, so again, when do we use trig? When we have only one side and an angle. And then another important thing is, what is something like this? What's tangent of 28? What's the sine of 71? Well, it's just some decimal. Okay, but instead of writing that decimal, we're just leaving it like this while we do our algebra, because this gives us our exact answer when it's written like this. Okay, now, kind of the shortcut I was going to talk about earlier. Whenever you have your x in the denominator of your fraction, what ends up happening? Well, you multiply by x to bring the x up here, and then you divide by this thing to put it down there. So basically the x and the trig function part here, they switch places. And that's what we ended up with, was x equals 15 over the tangent of 28. So basically, if you get a problem like this, well, you can just kind of switch these, because that's what's going to happen when you do the algebra steps. Okay? Again, another option is to use your other angle, and then we wouldn't end up with x in the denominator in the first place. That will only work for tangent, though. Okay? If x is our hypotenuse, we're going to be stuck with x in the denominator, whether we use sine or cosine. In other words, no matter which angle we use. All right, two more on this first page, and then we got the back page. All right, so same thing here. We're given one side and one angle, so we know we need to use trig here. Okay, well, which trig function are we going to use? Well, let's see, in relation to our angle, which is 65 degrees. Again, we could use this angle over here, which would be 25 degrees, but we'll just stick with the one they gave us. In relation to that angle, they gave us the, well, this is definitely the hypotenuse across from the 90, and then the other one next to it is our adjacent side. Okay, and then which trig function uses adjacent and hypotenuse? Well, again, so use SOHCAHTOA up here. Adjacent and hypotenuse, that's going to be our cosine function. Okay, so then we know that the cosine of our angle, because again, it's always of an angle, we'll do it right here. cosine of our angle, which is 65 degrees, equals the adjacent side, which is 8 root 5, over the hypotenuse, which is x. Okay? All right, now like we just talked about, since we got x in the denominator, I know when I multiply by x, it's going to move the x over here, and then divide by that thing, it's going to move that down here. So we can basically just switch those things up, and we know x is going to equal 8 root 5 over cosine of 65. Okay? All right, and then that's pretty much our answer. We just want to punch that in the calculator. Now, one thing you want to be careful of is, make sure you have 8 and the root 5 divided by that thing. If you're ever not sure if something's going to work right, it never hurts to put it in parentheses in your calculator. Okay, so for example, here we got 8 root 5 divided by cosine of 65. So then for the 8 root 5 part, trying to get where there's no glare, if you want, you just put it in parentheses, just to make sure. 8 times the square root of 5, and then I want that whole thing divided by cosine of 65. Okay, and then we get about 42.32, so we'll say about 42.3. So x is approximately 42.3. Okay, and then that's our answer we're looking for, because again, they said round to a decimal. In fact, you know what? One thing I've been doing wrong, I've just been rounding to whatever looked nice. It did say round to the nearest thousandth, so I probably should have gone to the third decimal place, so 42.328 if we want to go to the nearest thousandth. Okay, so 42.328 if you want to go to the nearest thousandth. Okay, all right, but nearest tenth, that's fine. We still get the idea of the notes. Okay, all right, one more on this front page, then we can move on to the back page. All right, so this time we are given two sides of our triangle. Okay, great. Can we use the Pythagorean theorem? Well, sure, if we want to find the missing side AC over here, but we want to find our missing angle. Okay, so when I'm trying to find a missing side of my triangle, like examples, A, B, and C. Okay, let's look at B, for example. If I'm trying to find a missing side, and I have one side and one angle, that's when I want to use trig. Okay, I use, tangent or sine or cosine, whatever it happens to be. If I'm looking for the missing angle, and I have two sides, well, that's when we want to use the inverse trig functions, which again, hopefully you remember from last year. So the inverse sine or the inverse cosine or the inverse tangent, which looks like, as you can see on the calculator, looks like it says sine raised to the -1 power, cosine to the -1, tangent to the -1. Well, that's just the notation for the inverse of our trig functions. Okay? All right, let's worry about our equation first. What's our equation going to look like? Okay, well, we're going to find that angle there, and then in relation to that angle, which two sides do I have? Well, I have my adjacent side here and my hypotenuse there. So then we want to use cosine again. That's our adjacent side over the hypotenuse. Okay, so then I know that the cosine of what angle? Well, that's what we're trying to find out. So the cosine of some angle equals the adjacent side over the hypotenuse, so 25 over 31. Okay, so I know that the cosine of some angle equals 25 over 31. And then how do we find that angle? Okay, well, basically we just punch this into our calculator, and this is what it's going to look like in our calculator. I want to know the inverse cosine, which looks like this, of this ratio gives me what angle? Okay, so x is going to equal the inverse cosine of that ratio. So this is how we want to punch it in the calculator. So here's our equation. Again, the cosine of some angle equals 25 over 31. And to find that angle, I just punch it in my calculator like that. Okay? Sorry about the glare there. Try to get it where there's not as much of a glare. Okay, so to use my inverse cosine function, let's scoot this up a little bit. That's the green button above my regular cosine button. So then I got to hit second to use the top row of things. And then hit that, and we can see, yeah, it says cosine of the -1. Again, sorry about the glare. And we want the inverse cosine of what ratio? 25 over 31. So then punch that in our calculator so we get it where we can see it. And then that'll give us our answer. Okay, so then our angle is about 36.249. So they said to the nearest thousandth, so we'll do it this time. 36.249 degrees. So x is approximately 36.249 degrees. Okay? All right. That is the front page of the notes. And then the back page, let's split up these videos. These are getting kind of long. So we'll pause there and do a second video.